We already finished with question one, right? Okay, I think we did. Okay, we haven't started with two. Okay. Mr. Fabrice, were you the one that said you'll be joining on your way back from work?
That's Joseph. I saw his message. That's Joseph.
Oh, okay.
Mm-hmm.
Yeah, then that means we can go ahead then. Okay, oh, before we get started, does anybody have a question? DT, do you have any question, any doubts?
No, I saw that you had a chance to grade my assignment. Did you have any comments you wanted to talk to me about?
Yeah, I think I already passed them as private comments. Did you see that?
Okay. I didn't, but I'll take a look now.
Okay, okay.
All right, thank you.
Yeah, you're welcome. Oh, that means I need to tell these other class. Whenever I review an assignment, I used to give private comments. I don't know. I mean, I don't know if Google Classroom doesn't notify or
I have
okay.
a question.
Okay, sir.
Yeah, let me share my screen, okay?
All right.
Please.
I know it's all right.
I'm trying to understand why this thing does what it does. So let me share this. Let me share this one. Share. Let me know if you see it.
Yeah, I can see your screen.
Okay. This is like the last assignment that I did. And usually, like sometimes, even though I put like comments, but let me see. I'll try to run this one. Okay, so this one did run. Okay, I'm gonna run. Hold on. Let me do this one. Okay, you see. Hold on. Okay, let me try this one. Enter a number. Five. Okay. Let me move this one. Okay.
Waiting kilogram.
Okay. Enter the width. Hold on. You see why this thing keeps on doing this. Enter the first number. Enter the second number. Uh, something is not right. Uh, is it this one?
I mean, everything is working fine. Or
Okay. All right. Let me see something. Control S. Oh no.
or you
Control
can
S.
comment the part that doesn't raise any issue and just run the part that is giving you the issue.
Okay. So let's see. Okay. Let me see this one. Like, um, the issue I encountered is like, there was a time where there was a moment where when I run, for instance, this one right now, this one that I highlighted,
Okay.
okay? When I run it, let me see. Yeah, when I execute it, let me get this
No, if you want to run that line alone, you have to comment other lines so that it doesn't take.
one. Other lines like,
Yeah, comment every other line that you're not interested in running.
uh, but like, okay, like,
Yeah, you highlight them.
okay, and then okay,
You do control forward slash.
uh-huh. I
Okay.
did that, but for some reason, okay, maybe, okay, let me see this one. Let me see this one. Run. Okay, enter number. See this one.
Can you undo?
Yeah, I'm going to undo.
I mean, your code
Uh,
is already running.
undo. I'm gonna undo again. Okay. All right. So it's already running. Yeah. So if I put 9, okay. And then why does it say enter another number again? You see? Or maybe it's going to
It's
the next
running.
one.
Your whole script is running.
Oh, so if you don't want the whole script to run.
You know, this is different from I guess why you had to select a line of code and run is probably you're used to SQL, like
Mm-hmm.
SQL, but it
Yeah.
doesn't work like that, yeah.
This one. Oh, okay.
You cannot just align a line, I mean a part of code and run it. You have to comment the part you don't want to
For it not to run.
for it not to run, yeah. So that was what I
Oh, so
was saying
whenever
that
you say like execute, it's gonna execute the
the
whole
whole
thing.
script, the whole code from top to bottom,
Oh, from top to bottom. Okay. So if you don't want something to run, you just put
you just
um
comment it down.
the pound. Okay, you comment. Okay, no
Yeah,
worries. I get it. All right. Thank you, sir.
yeah, you're welcome.
I'm gonna stop sharing. Okay, good.
All right. So for this second one, the question says a simple way to estimate the number of words in a string is to count the number of spaces in the string. Write a program that asks the user for a string and returns an estimate of how many words are in the string. So the way you go about this is, you know what the question is. You understand the question first, right? And you know what the question says. So try to do it manually to see the pattern that you want to program. And doing it manually is saying, we know we want to count, we want to estimate the number of words in a string. And the question even give us like a pattern. It says the way you know it is to count the number of spaces you have there. Now, let me see how real that is. Let's say we have a statement that says, my name is Gideon. I am a man. Full stop. The question told us that we have the number of spaces gives an estimate of the number of words that you have. So let's check. We have, this is one space, 2, 3, 4, 5, 6, 7. We have 7 spaces. Then let's see if it is equal to the number of, let's see if it is equal to the number of words that we have. This is one word, 2, 3, 4, 5, 6, 7, 8. Okay, something is going on. We have spaces equals to 7 and words equals to 8. Let's give another example. Let's try another thing to see if that's actually the pattern or if this one is just like an outlier. If actually the number of spaces equal to the number of words, then we can say another one. We are starting today's class early. Let me say that way. Now, how many spaces do we have here?
Seven.
Please. Okay. How many
I
spaces do we have?
counted 7. I counted 7. So let's say one, two,
I'm talking about
three.
this. This is the string. Like this
Oh,
is the
okay.
sentence.
One, two, three, four. One, two, three, four, five.
We have 5.
Five
But
or six.
how
Okay.
many words? We have 5. This is not part of
One,
it.
two,
Just this like a
three,
comment.
four, 5, 6 word.
We have 6 words. So if you continue like this, you see that okay, actually there's a pattern, and the pattern is that the number of spaces plus 1 will give you the number of words that you have in your statements in your string. Then
Hmm.
it is that logic, it is that pattern that we are not going to write our code to follow. So basically, the question says we should ask the user to enter anything. Then we can just say you already know how to do that.
Mm-hmm.
We can call it user str, that is user string. I would say input, And of course, we don't need to convert inputs to anything. We needed it as a string. And of course, it's coming as a string. So enter a sentence. And I mean, the prompts could be anything, but I just want to make it more descriptive. So enter a sentence and I will tell you the number of words in it. And after that, so we can create a variable to get, of course, we need to get count the number of spaces, right? And you also know that there's a count method. There's a count method there's a string count method, which when I gave you an assignment, you had to research. I think I also I also used it as an example in class. So we can say n underscore spaces is going to be whatever the user has entered dot count. And of course, so you're going to put the what you want to search for as the first argument. And of course, since we want to search the whole of the string, so there's no need to specify the start and the stopping index. So we just have to do user.string.count. And you know this, if you read the documentation, or let's say you've forgotten, if you read the documentation, you see it says it returns an integer. Before now, in documentations, they will write it there. When you see document, you see return. You see like a doc string that says it returns a string. But I think after some time, the Python started using there's what we call typing in a way. That is, you can define you can now enforce data type in Python basically. But let me not delve into that. So now, uh, another way to tell you that another way to tell what a function returns, or the type of value a function is going to give, is going to return to you as its result. This is how they do it. You see these forwards, hyphen, then greater than sign.
Mm-hmm.
Yeah, so that's why that's how they tell you. This is how they define a function. And after we'll talk about, by next class, we'll talk about how to define a function. But just know that this is the part that tells you what the function returns, if
Okay.
at all it returns anything. Yeah. So this is one way you can get to know that. So you see, it says it's going to return an integer. That means when you count the number of spaces, it's going to give you a numeric value, not a string. And of
Okay.
course, once you know it's a numeric value, you can do computations on it, right?
Yeah.
Yeah. So now that we've gotten the number of spaces, and the pattern we want to program says that when you count the number of spaces, you should add one to it to give you it's still an estimate, of course, because we don't know if there can be a break in the rule or anything. So, but then we know that once you add one to it, there's a high chance you get the estimate, or like the exact number of words that you have in your string. So we've got a number of spaces. Let's leave it like that. And let's say n words. N words is now going to be n spaces plus what?
One.
Plus one. And like that, we can say uh there are n words in your or in your string. Let's just put that in your string. So let me remove all this and let's run it. Okay. So we are expecting to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is right. So is there anything not clear here? Yeah? Hello.
Mhm. Wow. Mm, wow. Okay. Yeah. So okay. After that. So okay. So and okay. So I'm gonna try to. um,
Is there any part that is confusing or
Okay. Let's go over it again. Just finish one. So
yeah, all right.
user underscore string equal input.
So
Enter a sentence, and I will tell you. Yeah.
let's see the question. Let's understand the question first. So the
Yeah.
question already gave us an hint and says a simple way to estimate the number of, let's say we didn't even have to confirm that rule, but the question already gave us like there's a pattern. And it says that a way to estimate the number of words you have in a string is to count the number of spaces in that string.
Mm-hmm.
Because of, I mean, a curious, because you're a programmer, you have to be very curious. So we want to know how true that is. And that was how we had to, write our own strings manually and check if this
And then
pattern is
see
actually
the
true.
pattern. Yeah.
Yeah. And of course, we saw that, okay, the number of spaces plus one will actually give you the number of words in an
Mm-hmm.
ideal, with an ideal sentence. So then, okay,
Okay.
then that means the pattern we want to program is, and the program also says, write a program that asks the user for a string and returns an estimate of how many words are in the string. So because we already know what the rule is,
Yeah.
so what we need to do to write that to arrive at the solution now, what we need to do is
Mm-hmm.
to first of all get the input, the word.
Yes.
Like that's how to go about solving the problem. Get
Mm-hmm.
the word
Yeah.
or thing. And after that, after you've gotten it, count
Count.
the number
Mm-hmm.
of spaces
Of
in,
species.
and after that counting the number because of the logic.
Mm-hmm.
Uh
Just add one.
so yeah, add, you can say add one to the
Mm-hmm.
count of spaces and to get number of words. And after that, you print or output the results.
Mm-hmm.
So pretty straightforward. So maybe before you solve any problem, we should always, first of all, always write it out like this and see if it actually makes sense.
Mm-hmm.
So that's exactly just what we've done now. We got an input,
Mm-hmm.
we count the number of spaces, we add
Yeah.
one to it, and we output the results.
Mm-hmm. Yeah, it makes sense.
Very good.
Yeah.
So for number three, says write a
Mm-hmm.
program that asks the user to enter a string. Okay. The program should
So
create.
hold on. Before we go to that one, I'll try to run it on my own. I get some funky stuff.
Okay.
I don't know why I made the mistake. Trying to figure this thing out. I'm looking at it. Oh, okay. I think I forgot something here. Okay. Uh, species plus one and underscore species plus one.
Yeah. Ditsy, I'm not sidelining you.
Okay.
Again, like you got all this right. So that's why I'm not really
Mm,
like I'm not really focusing on you per se. But if you have any contribution, you can let me know. Okay.
Okay, yeah.
Uh, you did a very good job in your submission.
Well, I would say that when I was thinking about it, if you basically have a space for every word, or like every other word, then you just have to add one space in order to get the max amount of words because there's a space. You know what I mean? Like it's like there's n minus one spaces. So if you plus one, then you'll have n words.
Yeah, exactly. Exactly. That's like the same pattern. Yeah.
Mm,
Because if you have I think what he was saying was Mr. Fabrice, what he was saying is if you have let's say you just have a word like this
mm-hmm,
is one word, and I mean it's just basically the same thing we've been talking about. It says uh the number of word is n minus one. I mean the number of spaces is n minus one. That is the number of words minus one. Like when you have Gideon, just Gideon now. This is one word. And to get the number of spaces that
mm-hmm.
you have there, subtract one. That means you have zero spaces.
That's right.
Yeah. So similar pattern. Just watch out for the pattern for there are a lot of string manipulation tasks like this. So when you come
Yeah.
across them, most of the time you just have to get a pattern that you can replicate.
Uh-huh.
Yeah. With all algorithm, basically, what you're trying to write is you're trying to repeat I mean, write a pattern that you know that
Okay.
is true. Try to write it and get your result.
Okay.
So can we move on to the third one now?
Yes. Yes, yes.
After this one, trust me, the exercise will be more tedious than this.
More tedious than this one.
Yeah, I believe I'm actually, I mean, I believe you're getting better. So
Mm-hmm.
I'll give you like a befitting question also. As you reach each
Okay.
stage, a
Okay.
befitting question. Yeah.
Mm. Yeah, we can move to the next one. Yeah, mine is running now. I'll find out what
Okay.
the mistake was made, but it's running now. So
You understand everything, right?
yeah, correct.
Okay, right. So the third number three says write a program that asks the user to enter a string. The program should create a new string called new string from the should create a new string from whatever the user has entered. Call it new string from the user string, of course, yeah. Such that the second character is changed, okay, to an asterisk, and three exclamation points are attached to the end of the string. Finally, print new string. Typical output is shown below. So we are given, let's say you don't understand all this grammar,
Mm-hmm.
which of course very simple. This is an example here. So you want to ask the user to enter a string, and let's say the user enter qbits. This is what the
Mm-hmm.
output is going to look like. You replace character, the
With
second
an
character of that
asterisk
string with an asterisk, and I mean use the rest, and also add three exclamation points
at the end.
to it. So this is what we
Mm-hmm.
want to have. This is like the pattern to it. So
Okay.
can you tell me let's write the algorithm now. Let's write out the way to approach it.
So we are going to input first our string.
Yeah, input the string.
Mm-hmm. The initial string. Okay. Okay.
Then
Once then it says the program should create a new string. I mean a new string called new string from the user string such that the second character is changed to an asterisk. So we can say new string equals. I mean that would be like a variable, or we're
yeah,
gonna assign new
we
string
call this
equal
create new string
create new string from the previous one. So new string equal
from the
we
input.
in yes from the input string,
Okay.
and then from the input string, and we're gonna add this modification. Replace by replacing the second character with an asterisk. Uh-huh.
Replace second character,
With an asterisk.
second character with
Mhm.
an asterisk.
Yeah.
Okay.
And add three exclamation point at the end.
Add at the end. Okay. And lastly,
Lastly,
you
print
output the result.
or
Yeah.
output. Yes. Hmm.
I mean, this is right. This is right. It now comes to the implementation.
That's right.
Yeah. And for of course for the implementation, you have to play by Python rule. You know that already, right?
Yeah.
Okay, good. So first, let's get the user input. Let's call it
Hmm.
user str, and you know how to write the command. Enter a string or enter a word. Let's say enter a word. So we've gotten that. Now create a new string from input string. You just to do that, you could have, I mean, you first of all think you have to do this new new string, you call it user str, right?
Yeah.
Now replace the second character with an asterisk.
Yeah.
Replace
So
only works. Now let's do that. Let's write it. But you come to a realization that replace only works when you know the exact character you want to use or the exact
that's why
character
by
you want
this
to
point you don't.
exactly.
Okay. Meaning like if you know it's gonna be R that you're gonna replace, then you can say replace R by B, for instance, or by asterisk. But since this one we don't know, it can be anything basically.
Yeah, exactly. It can be
Okay.
anything. So, but there's a way you can play around that. Though I wouldn't recommend this exact. I would not recommend this solution. Well, I mean, it's also
Okay.
recommendable. You can use the solution also, but I'll give you another solution. But let's say we want to actually go about replacing that truly. We want to replace the second character, right? But we don't know it. But how
Mm-hmm.
can you get the new character?
How can we get a new character?
I mean, sorry, how can you get the second character from a string? Replace takes what you want to replace first
We
with what you
can,
want to replace it with.
yes, we can do the slicing by doing this thing. Like you see the way we do the slicing, where where we
Indexing,
count from
actually.
zero index. Yes,
Indexing.
indexing.
We can do indexing.
Yes,
Awesome.
yeah.
So let's do it like this. Are we using, okay, let's continue like this. I'll still make the necessary corrections later on. So then we are picking the second character, right? So new string of one. Is that right?
Mm-hmm.
With what are we replacing it with?
Asterisk,
With asterisks.
star.
So this is going to do the work. But remember, the change will not, I mean, the change is not permanent.
That's right.
The change is not permanent. So that means we have to overwrite new string itself. Like overwrite it like this and say new string equals to whatever new string used to be. But remember, new string used to
Mm-hmm.
be what user in this thing used to be. So we are saying now replace the asterisk, I mean, whatever is in the second character, replace it with an asterisk. And now overwrite what we already have in new string like that. So new string will now be whatever this changes is. Whatever the changes
Mm-hmm.
of this result is. You understand that code, right? That part.
Yeah. Mm-hmm.
And after that, new string is already something. Let's say the user enters qubits. The new string is already q asterisk ert at this point.
Mm-hmm.
Let me put a comment there. So let's say the user enters qubits. At this point, new string is also going to be qubits. And at this point, it's going to be q asterisk et. And now we want to add what was it called to the end? Triple exclamation to the end. So if we
Mm-hmm.
do new string, I know this new string is what? What is the value that this new string is holding at this point?
The new string will hold the yes plus the new string.
I mean, like this new string, what is the value? What is it holding at this
This
point?
one is holding the, the Q star
ERT.
ERT.
Exactly.
Yeah.
So now that means we also our new string is should also
Again,
we always aid the, I mean, should always hold the updated value, right? So that means we need to
yes,
overwrite it
that's
again
right. Uh-huh.
like this, and we should have our result like this. We should have, if we print new string, let's see. Let's try it with the example that was given. Cube. We have it working fine. Let's give another example. Let's give it Gideon. Then we should have G star Dion 3 exclamation. Is that correct?
Yeah, you got it. You're right.
Got it right. So this is one way. This is one solution. I mean, this is also, I mean, this is also acceptable. But one way to, but this is going to take more spaces in the sense that we have more well, no, it's not going to take more spaces like that per se. But I mean, another way we could optimize this code is to, instead of having to do all these do the replace with new string and the likes, we can
Mm-hmm.
just say from the user, since you know that once if you do replace, it's not going to change the it's not going to change user string or anything. So at this point that we are
Mm-hmm.
making the copy, we can just say whatever you have inside a new user, user string, replace it with
Mm-hmm.
what is in user string position one that is going to continuity. And after that, you can even just do it in the one line. See, after you've replaced it, then you can do add 3 exclamation.
So you're trying to shorten the program.
Yeah, shorten the program. Like it is even more
Yeah.
readable. So you have to avoid having to overwrite user string all the time. I mean, overwrite new string all the
Mm,
time. So with this, if you run this also, we should have Q. Let's you have Q beds. Yeah, you have that.
wow.
Right again, you have Gideon. You have G star. So that is one solution. Then another solution is, say you have our user string like this.
Mm-hmm.
Say you have our user string like this. We got our user string. To create the new string based on the pattern, the new rule that all this, to summarize all this, create new string from the
Mm-hmm.
user this thing. We can take the first element, since what is the I mean, if the user enters this, if the user enters
Mm-hmm.
this, what pattern actually gives this? And the pattern is taking the first element in what the user
Mm-hmm.
enters, which is going to be qubit of 0,
Mm-hmm.
plus whatever the user enters. After that, it is followed by an asterisk, right? So you had an asterisk to
Yeah.
it.
Mm,
You add an asterisk to it. Then it is followed by everything in what the user enters aside the first character.
mm-hmm.
So which is going to be slicing starting from 1 till the end.
Yes.
You
And
know
then
this is going to
add
be, yeah. Then after that, add
mm-hmm. Pass.
3 exclamation.
Mm-hmm.
And voila, you have your new
Wow.
string, which still follows the same rule. If you have qbet, you see we have that. If you have Gideon
Mm-hmm.
again, you still have G star Dion.
Wow.
It's straightforward.
This is a
So,
proof that you can write a program
and it can
you
be
can
different,
use.
you can have different approaches.
And
This
yes.
particular one actually just try to replicate the pattern itself.
Mm-hmm.
Like replicate the pattern. But either ways, everything still follows it still follows the algorithm we wrote.
Yes,
Like you
that's
take
right.
the inputs, create a new string from the input string. And of course, the new string is actually what's going to take the whole modification and everything. So after inside this create new string, then you can now say for this last algorithm that we use, that's when you have to do in this one now you have take you can say create the new string from the input string, by taking first character, uh, then add this thing aesthetic. You can just write it that way. But whatever approach comes to your mind first, you can try to see and implement that. Then later on, you can now wait and the way I go about this is after you've written the one that comes to your mind, you can ask, okay, is there any other way I can approach this if there is time actually? Most of the time, there's always one way you can. I mean, there's always more than one approach
Yeah.
to. There's always more than one approach to solving a question.
Mm-hmm.
So that is that about that. Any question, anything?
No, this one.
So I
I mean,
believe
when you look,
you're already
yeah.
picking like the brain of a programmer now, like how to think like a programmer.
Okay, thank God. Thank you for saying
Yeah.
that. That encourages me.
I mean, that's just the rule. That's actually what you when you see when you're watching things like this, what
Mm-hmm.
maybe unknowingly to you, you are picking how
Yeah.
to think like a programmer. And the next time you have similar task,
Mm-hmm.
you tend to think in that way. Yeah. So you wanted to say something?
No, no, no. I wanted to say that in the beginning, when you look at the wording, like the question they're asking you,
Yeah.
it seems cumbersome. But when you put it down, like you see, before starting this thing, you put like a comment, where you comment, input the string, create. This one, when you break it down like that, it makes it more, uh, you know,
It's more simple. That's how you approach every
yeah.
question. The reason
Mm-hmm.
why before now, the reason why I wasn't having to write this was because I've had many experiences, and these ones are actually this task looks very simple to me. So that's that. But ideally, if you have a problem, if you're trying to write a program, they call this
Mm-hmm.
algorithm. You write out algorithm like step by step process of how you're going to
Mm-hmm.
solve it. So
Okay.
we even use diagram. We use diagram to sketch how you're going to write your logic and all that. Well, this is like a best
Okay.
way to start.
Okay.
Just started like this. So when you have problem like that, try to break it down and then try to implement what I mean, the outlined process you've put down to see
Mm-hmm.
if it can actually work. If it doesn't work, they can go back to tweak it based on your knowledge of Python already that you already have. Some will be easier and I mean,
Mm-hmm.
some will be implementable. Some you may have to do some little adjustments.
Mm-hmm.
But then outlining the process out like this will help you with with writing the code. So I think this is the approach Mr. DT used.
Mm.
Mr. DT,
Nice.
DT, am I right?
Yes.
Okay, yeah. So let's move on to number 4. Write a program that asks the user to enter a string S and then convert S to lowercase. Remove all the periods and commas from S and print the resulting string. You should be able to tell me, I mean, you should be able to dictate the code for this. Should we give it a try?
Sure.
Calm down. Every question you have here is something you can solve that I'm sure you can solve. So you have it in you.
And
So let's write the algorithm
mm,
first.
mm-hmm. So that would be the same thing. If input the string, if input the string,
Okay,
yeah,
input the
input the
string.
string, okay. And it says input the string. Is it
Input a string
S?
S. Let's like add the variable name to it. Okay. Input a string S.
Oh, so just the string is only S, okay. All
No,
right.
like
And
that's the
then,
variable name.
yeah.
Yeah.
So,
Let's call
okay.
that string S. So
Oh, okay. Okay, I see. Okay. Oh, all right. And then convert that string to lowercase. Okay, convert to lowercase. Then
convert S
remove.
to lowercase.
Mhm.
Okay.
Then next one, remove all the periods and comma from S trim. Oh, okay. And print, and then all the convert to lowercase, and then remove commas and periods and comma. I don't know if we can do it in ones or two lines. So we're gonna remove comma first, then remove.
Just step by step. See, when you're writing this algorithm, don't try to combine
Okay.
logic. Make
So,
it step
all
by
right.
step. Yeah.
Let's remove periods.
Is the word remove?
It says, yeah, it says lowercase removes all
Okay. Okay. Yeah. Remove.
the
Awesome.
remove all periods, all
Remove
the
all
periods and comma
periods.
from S.
That is one. After you remove all periods, then
You
remove.
gotta remove, okay, comma.
You can even let's write it together. Let's say you but the reason why I wanted to write it out is because in Python you cannot okay, let's just go.
Yeah,
Let me
that's why I was trying to see if we can do it in one line or okay,
yeah, remove all dots and
from S
comma.
and then print out the result. So and then output the result.
So now this you have a template. Now dictate the
Hmm.
code for me.
Okay, so the code will be S equal input a string. So enter a string. Yeah.
Enter a string. Okay. To the next line.
And then it says convert S to lowercase. All
So
right.
you can
So
call that S lower. If you do S
yes.
dot lower without assigning it to
Uh-huh.
anything, it's just going to change it at that instance. So we need to store
Yes.
whatever we've, of course. So, let's call it another variable
Mhm.
called S lower
Yes. S lower
equals
equals
to S,
to
equals to
to
S,
and then lower
I think, what's the
S
word? Yeah, S dot
lower
lower.
and then input
Input. What are we
no
inputting?
no 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 S lower and is it enter here will be enter a string no S so this one will so yeah this one will leave it like this because the lower will act on the S so he's gonna put everything
Yes,
S
you're right. It's going to
so we'll
convert it to
leave it like
lower.
this
We've
yeah
sorted that part out.
mm-hmm.
Then what else?
Then uh the next one will be so we already converted the lowercase okay and then the next one remove all that and comma all things so this one will be so how we're gonna call this one we can call it
Let's say S, no.
S no comma I mean no
Is it
no
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 dots
period no
or
that
no
okay
period? Let's call it no period.
mm-hmm.
Are we doing it together? No period and comma, right? Or
uh I wanted to do it like separate but if you want we can try to do it
you are the driver now. I'm just the you are the captain.
okay
I'm just
okay
the one handling the wheel in a way. Yeah.
all right so then so this one so equals let's do it one by one for now.
Okay.
I'm not a professional like you. I want to go step by step.
No, of
So
course, that's how
S,
you start. Even if you're going to optimize later, you go like
yeah,
this.
so now equal. So now this one will impact the S lower. So
Yeah.
so add yeah, add to so this one will impact the S lower.
And what are we using
Now
to do the removing? The
is
removal.
it the is it the trim? I know in Excel is it trim or no. So let's remove it. So we're gonna replace that with space or what?
Are you
Replace.
definite? I don't want to help you.
Okay, so I'm gonna use the replace and then you can correct me. Okay, so replace that.
Okay.
Okay, replace da da da. Replace okay that with empty space.
What is okay? Dots? You mean dots, right?
Yeah, the point yes
Okay.
with empty like comma yes and then brackets again. I mean
Parenthesis,
apostrophe
apostrophe. Okay.
and then empty in there. Maybe do two. Do
Like this.
two. No no no. Do code like the first, like the one you did, the first one,
No, no,
two
this
brackets.
is still going to work.
Easy. Okay.
It's good.
So
Python
let's
allows, remember, to define a
either
string,
one
Python
of those.
allows single or double.
Okay. All right. So let's do single,
Okay. Would
and
that be a
then
space?
yes, will be a space in it.
Really?
What do you think?
It's not what I think. It's what you think.
Yes, I would say yes because a space is a string. So we're gonna leave it with a space. So yeah, leave it like that.
Okay, let's go by that. Then you realize where you've. Okay, so then
Yes.
also
Also,
S,
S no underscore no comma
no period,
no pe
no.
yeah no period no comma. So that one
I
will
think let's do something. Yeah, let's just sort of can say S no. I mean S lower. Let's call this S lower, no period.
yes.
Then this one we can say S lower,
S lower no period no comma.
no period, then no comma.
Mm-hmm.
So that's going to be
But
S
that will be
lower,
S lower that
no period,
replace uh-huh.
replace comma, right?
Yeah,
With
yes. Uh-huh.
okay,
And
and
then
print S
print
lower, no period, no S lower, no period, no
yes.
comma.
Mm-hmm.
Wow, you've cooked. So let's see if it tastes well or not.
Mm-hmm.
So
My
let's run
God.
this. And I said,
Mm-hmm.
you cooked
Mm-hmm.
well.
Okay. Period. Okay.
Uh, I want something to be feasible. So after the dot, I'm not putting a space or anything. So I mean, will I be right or will
Mm-hmm.
I be right? So let's see what the output is. I said,
You cook well.
I mean, it actually does what I mean, there's no space, there's no comma that's been removed. You did well.
Mm-hmm.
But there's one thing I wanted to point out. You see, we have two spaces here.
Uh-huh.
So what you've done is you did not remove the dots. You only replace it with another character, which is a space. Empty
Mm.
string is not a string with a space. Empty string is a string with no value inside, with no character inside.
Oh, okay. Okay. So yes, so now you're gonna close it. Okay.
Yeah. So removing
Okay. So
dot
now
is same thing as replacing it with an empty string,
okay,
which
okay,
is a
okay,
string with
okay.
no character inside.
That's extra space, extra character.
Space is an extra,
Okay.
is a character also. It also counts.
Okay.
If you check the length now, let me quickly show you that because it's very important that you know this. If
Mm-hmm.
you do length of, remember length, right? Length is what gives you the
Yes.
count of a
Yeah.
character. If you do length, this string
Mm-hmm.
has a space, it's going to give us one.
Mm-hmm.
So if you do
That's true.
length of an empty string, one with no
It's
space,
gone zero
is zero.
because there's no space. Okay. That's a very
Yeah.
good thing that you explained this to me. Okay. So yes, we wanted to, but what I did there was to replace the comma and the thing with a space, which is a
Yeah,
character. But we
which
don't
is a
want that.
character. Exactly.
We don't want that. We just want to remove them.
Yeah. So let
Okay.
me have this again.
Mm-hmm.
Uh, so now you say I said you
Okay.
cooked well. Will I be right? So good. I
Mm-hmm.
mean, the solution is right, but you
Okay.
can also optimize it in a way.
Absolutely. Yeah. There's always a better way to write a program. That
Yeah.
I will always
So,
keep in my mind.
I mean, this is actually like I can't think of any other way. But the thing is,
Mm.
we've overused our variables here. We
That's
overuse,
true.
we have a lot of variables here. So
Mm-hmm.
there's one thing we can do. We can
Yeah.
actually make this a one-liner.
One line. Wow.
We can do this in one line. And what we're
Mm-hmm.
going to say here is, I mean, it's also going to open you to a way you can write your code in Python.
Mm-hmm.
This particular command, what
Yeah.
it does is, it's going to collect something from the user, right? This particular thing will resolve into a single value.
Mm-hmm.
You know that, right? Which is whatever the user enters,
Yeah.
right? Now we can now want to say, okay, after this thing is going to be whatever the user enters. It's going to internally is going to resolve into just a single string value.
Mm-hmm.
And now we can now say that string value that the user is going to enter, make it lower. So we can now call dot lower on it.
Mm. Oh, wow. Okay.
What we are
So
saying is
enter it and then
the output of this statement
uh-huh.
dot, it's going to be a string, right? So we are now saying
Yes,
apply the dot lower to that
that's
string.
true. Mm-hmm.
And after we've done that, we can now say this is
Yes,
also now going to result into a string.
that's true.
You know that, right?
Apply. Yes.
You can now say dot replace. You can call dot replace on it also.
Mm-hmm. Wow.
And
And then even this one we can do instead of doing two replace it, can we do like just one? Where we can add two? Oh no, no. Okay.
no, replace only takes
One.
one
Okay.
character that you want to replace
One
on
at a
one.
time.
So that means we are going to be repeating replace multiple times. Do you know what I mean?
Okay.
So now
Wow.
we can do
Remove
away
all
with
this thing.
all this
Phew.
and just print our S.
Just print S.
Yeah. So if we do, I said this is awesome. Let me put a full stop there. So you see, I said this is awesome.
Wow. Oh my goodness. Wow. I think, like you said, yeah, yeah. So, okay, I get it. I get it. This one, you made it very, very simple, and I understand it just right.
Yeah. Or better still,
Wow.
you can even, I mean, whichever way, now we only use the variable. We can say this is over optimized. I mean, for this thing, but
Mm-hmm.
though it is not, but just to tell you that the rule still applies. Let's say we want to say S lower, we still want to define our S lower. I'll say S dot
Uh-huh.
lower. So we can say, we can call the S replace, we can call it S final, and now
Mm-hmm.
say S lower. Sorry, S lower, that is the result, dot replace, and you can now call dot replace. Since these are two similar methods,
Mm-hmm.
so you know that,
Mm-hmm.
yeah, we can now do this. They call this
And then you're gonna print.
what's it called? Like a chain operation in a way.
Mm-hmm.
You chain the output of one statement of one expression is changed
Mm-hmm.
to another
Yeah.
like that. Yeah. So I mean, it still works fine. But I believe you know the logic. You know that you can do like a chain operation on the output of an expression without having to
Mm-hmm.
explicitly store it or anything.
Yeah. Yeah. Yeah.
Exactly.
Yeah. Okay.
If you
That
want to
makes
over
sense.
let's make one ridiculous, not ridiculous, not so ridiculous like that. But let's say we don't
Mm-hmm.
want to store anything in a variable.
Mm-hmm.
We can also pass the whole of that expression inside our print function.
Wow.
I mean, this should be expected. Oh, it says bar forgotten a comma. Oh, okay. This is not supposed to be there. Yeah. Yeah. So we have this. The whole of that expression. You put it
Mm-hmm.
in. So this thing still boils down to the fundamental. So you see,
Mm-hmm.
I said we are good. She said, I said we are good. So this thing still boils down, I mean, it falls down to this very
Mm-hmm.
fundamental that print is a function that
Mm-hmm.
outputs something. So the
Yeah.
only thing we are not that outputs whatever you give to it. And what we are giving to it is this expression, which Python,
Mm-hmm.
and if Python wants to run this, Python will have to resolve all these things you have inside.
Mm-hmm.
Same thing that will happen if you had to store it in a variable and call it S. You
Mm-hmm.
put S here.
And then print S.
So the thing is that Python start running from top to bottom. So Python will have already resolved this. We have already, resolved this into whatever the output is going to be and store it in S and now print
Mm-hmm.
it at this point. But
Mm-hmm.
if let's say we had not stored it in a variable, and we just pass
Yeah.
it directly into our print. We say print out this. So what Python
Mm-hmm.
will do is Python will go into, okay, this is print. You asked me to print something out. What do you ask
Yeah.
me to print? This is what we asked you to print. Now Python says that, okay, this is a command for me. Python will have to now
Mm-hmm.
resolve this, and
Mm-hmm.
whatever the resolution is what is given to print to now output.
Yeah.
So I
Makes
believe
sense.
this is well explanatory and like very straightforward.
Yeah, that's
Right.
right.
Cool. Then we can move on to number 5,
Hmm.
which says, I hope I am recording. I hope I am recording.
Yes, you
Ah,
are.
thank God.
You are.
Okay. So
When I first log in, that's what he gave me. He says
okay,
you are.
thank God.
Mm-hmm.
So number 5, we have when I was a kid, we used to okay, I think um Mr. DT did this one of our classes like that. So but this one is pretty straightforward, very straightforward. But let's see, let's read the grammar. But if we don't get anything from the grammar, then we look at the example. But I
Okay.
hope the grammar is actually going to be is well, I mean, it's simplified already. So when I was a kid, we used to play this game called Mad Libs. Okay, I don't know what
Mm-hmm.
Mad Libs is at this point, but let's see the
Yeah, me
explanation.
neither.
So the way it worked was a friend will ask me for some words and then insert those words into a story at specific places and read the story. The story will often turn out to be pretty funny with the words I had given, since I had no idea what the story was about. The words
Mm-hmm.
were usually from a specific category, like a place, an animal, etc., etc. For the problem, you will write a MADIS program. Okay, this is what they've explained what the problem, I mean,
Mm-hmm.
what the thing is, and this is what we are to do.
Yeah.
You write a Mad Libs program. First, you should make up a story and leave out some words of the story. Are you getting it? Are you following?
Yeah.
Your program should ask the user to enter some words and tell them what types of words to enter. Then print the full story along with the inserted words. Here is an example. Here's a small example, but you should use your own longer example.
Mm-hmm.
Uh, okay, there's an example. It says enter a college class. Okay, calculus. Enter an adjective, happy. Enter an activity, play basketball.
Mm-hmm.
Then, so this is the story. Calculus class was, you know, the college name or the college class
Mm-hmm.
was happened first. Was a really the adjective was put here. Happy today. We learn how to play basketball today in class. I can't
Mm-hmm.
wait for tomorrow's. Okay, I believe you get the logic now.
Yeah. Mm-hmm.
Okay. So the first is our story.
Mm-hmm.
Let's say
So
input. I mean, let's
input.
create a.
Yeah.
Let's, they said the question says you should. Uh, I'm
Mad
coming.
leap. Mad
It says
leaps program.
first this program first you should make up a story and leave out some words. So
Mm-hmm.
the first thing we'll be doing is make up. Let's make up a story
And then leave out someone. Okay.
and leave
Gotcha.
out some words. Okay. And
Mm-hmm.
after that, ask user, same thing as input, ask user
Input.
for the words left out.
Mm-hmm.
And after that, put the user words or
Into the
the
story.
user input into the makeup or into the story. Let's just say into the story.
Mm-hmm.
And that
Output.
output the uh
The
which is called,
final story or
but yeah, the final story. Thank you. It's final story. So let's go. Let's go say
mm-hmm.
story. So let's cook a story.
Mm-hmm. Input.
We want to cook a story, make up story. We
Oh,
are not getting the story from the user. Remember, I says we
okay,
should
okay,
make it
okay.
up. So it is like we are creating a template for the story.
It says enter. Okay, calculus class was okay. All right. So enter the story. Um, hmm, what can we?
It would have been fun if I actually if we had like an external person to assess this thing. We just come out. I mean, to make it to what actually makes it fun is the fact that the person you are going to ask the input doesn't know what the story is all about.
Uh-huh.
Yeah, so that's actually what makes it fun. But then let's just say
Mm-hmm.
we have let's follow this what they are there. Let's use this same story here.
Yeah. Okay.
Let's use this story here. So one thing is okay, let's not make this a one liner.
Mm.
You know how to write a multi-line string, right?
That one,
That you use triple
multi-line.
quote.
Oh yeah, you put okay, three.
That's how you create a multi-line string.
Okay.
Yeah, and it is important that you have this starting in the very like in the very uh leftmost, like the way I've defined it like this. It's very important like this because if I had
Mm-hmm.
to put this space is going to all these spaces we can't at this point.
Oh, okay.
Yeah, if you had to define it like this look good to you
Mm-hmm.
inside your own code, but when you print it out, these spaces will be included.
Oh, okay.
Let me quickly chip that in because most of these things is very important.
Wow.
Formatting your output, you see how
Mm-hmm.
it looks like. So you see we have
Yeah. Yeah.
calculus. You see the space is also included. But if I did
Mm-hmm.
not include the space,
Go all the way. Okay.
so basically what we've done here is we say this is going to be on the first line, and the
Mm-hmm.
next line, this is going to be on the
Okay.
and
And then
this
the next
class
line.
with exclamation will come last.
Mm-hmm.
So you see how it came now. Calculus
Yeah.
class was really happy. Yeah. So let's go back to leaving out some. You know how to put like an empty space, right? We want to create a story template, and we have to leave out some
Yeah.
words. So you know
Yeah.
how to create like, yeah, cool. So we would
Mm-hmm.
open
Yes, like this, and then
and then the adjective. Let's also put an empty
yes.
in there.
Yeah.
Then
And then basketball
activity, play
or play
basketball.
basketball. Yeah.
And yeah,
Okay.
so let's leave it like that. It will make
Mm-hmm.
sense. I mean, just to save time, that's why we're not able to come up with our own story. But we've come up
Yeah.
with a story template and
Mm-hmm.
we've left out some words. So
Yes.
let's call one. We can call this now. I'm just using the because that's actually how Mad Libs work. But let's call this now and say
Mm-hmm.
inputs. Want to ask the user
Input,
for the story for the what we've left out.
the
So
first bracket,
yeah, exactly. Enter the
enter.
or let's say
That
enter
one is
a college name
yeah, college name. Yeah.
or a college class rather. Enter a college class. So for
Mm-hmm.
that, then we have another one. So let's call it
Enter
adjective.
adjective.
We'll call it ADJ and enter an adjective.
Mm-hmm.
And lastly, we have an activity. An activity is like a this is not it's no longer a verb. We are
Uh,
something. Let's just say activity. Let's call it activity
yes. Mm-hmm.
and say enter an activity.
Yeah.
Enter an activity. And
Mm-hmm.
all those we now have our final story.
Yeah.
It is going to
Equals print.
I want you to tell me the code. What we want to do is we want to put what the user has entered inside our framework, inside
Oh,
our
okay.
blueprint rather. So how can you do
So,
that? Mind you,
final stuff.
we define our story before getting the input. So there's no way we can come back to say put now here. Put
There's no way we can do that. That's what I was gonna do.
no like this. is not going, oh, it's actually going to work, but
Yeah,
uh okay. Thing is, no, it's not even going to work. Or
it's
will it?
not.
Let me see. Let me see. Let me see. Let me see. It is not supposed to work, but because of variable, no, it's not going to work. It's not going to work. It's not going to work. Even though we use the same variable, it's not going to work. Math, let me call it math. Math, bigger, let me say bigger. An activity, let me say eat food. Oh yeah, it's not going to work.
It's not.
Yeah, it doesn't work. It doesn't work like that. I
Okay.
expected. So we need to fill the placeholder,
Mm-hmm.
and you already know it. I mean, we already talked about it, how you can use it. So how can you do that? How can you?
Hmm. No, we
You
can't
know it.
use
It's
it.
something you've been using a lot, a lot, a lot.
Is it print or no?
No, no, no. This
Um,
is just
final equal.
how do you put a variable inside a story or inside a string?
But you said that won't work, right?
The reason why this
Or
would
no?
not work is because we've already defined, no, you cannot use a variable before you call it. You cannot
Oh, okay.
call a variable before you define it.
Mm-hmm.
That's what I'm saying. If we put now here now, we are calling now
Yeah,
before we
yeah, yeah.
call it in our code. So that is the main reason why it's not working.
Ah, okay.
Yeah.
Hmm. So this one, final story equals.
If you want to, let's start like this. Because of our time, we have like just 20 minutes left on it.
Yeah, we got less than 20 minutes.
So if you want to fill this idea, let's say you want to fill this now, how are you going to write it? If you want, let's say you want to fill something at this point, how are we going to do it?
Yeah, let me see. Oh, you said we did it many, many times. We're going to do F, print F, or no?
Okay, so I think I get where the confusion is coming from now. When you want
Mm-hmm.
to use when you do like this and when you do like this, when you do like this, the F is not because you are using it in a print statement. The
Mm.
F is actually for the string.
Okay.
The F is for the string. So when you're printing it, you're just when you are printing it, you're just applying that. It's just like an expression. And that expression is, see, the only thing that concerns print is that give it anything, is going to output it to you. That is
Mm-hmm.
the work of the print. This is the actual, like the simplest print statement that you can have. A print without an argument,
Okay.
without anything to print out. So whatever you give inside it is an expression. So that F is not for print or anything. The F is for a string.
Oh, okay.
The F is for a string. So I mean, you can do
Mhm.
this. This is still not going to, yeah, this is not going
It's
to
not
work
gonna work.
because you are using a function before you are using a variable before you call. You are calling a variable before you define it.
Okay.
Yeah, so it's not going to work. But now that you know that this F approach is not going to work, there is
Uh-huh.
there is another approach for filling in variable like this into your string. You forgot
Mm-hmm.
the dot format, the format method,
Oh boy. Yes, yes, yes,
where you have to specify what you're going to use. But at this
yes.
point, if we put noun here, noun will come
Mm-hmm.
first, right?
Yeah.
If you put noun, it's still going to raise an error. It's going to tell us that we are calling a variable
Before using it.
before we
Oh,
define it.
before defining it.
We are using it before we define it. So that's still not
Mm-hmm.
going to work. But then this doesn't take away the fact that this is a string value.
Mm-hmm.
And now for our final story, you know the approach that we could have used it, save dot format, right?
Mm-hmm.
Now that we have our string, and our string has been stored in a variable called story.
Mm-hmm.
We can call that string now
Story
and apply format on it
formatted.
after we've defined the variables we want.
Mm.
You have
Noun, and then
adjective
adjective, and
and
then
the
activity.
activity.
So down they're gonna fill that in.
And now if we print that final story, we should
Mm.
put. So let me say
So
this
first
bigger
enter.
to stand out. That's why I'm writing it in uppercase.
Mm-hmm.
Adjective. What did I use the other time? I say it. Oh, sorry. Psst. Let me close. The adjective should be, I mean, the first thing is college class. And I
Mm-hmm.
want to say math.
Yeah.
Adjective, bigger.
Bigger.
And activity, eat food. And
Okay.
finally, we have math class was really bigger today. Okay. We learned how to eat food today in class. Oh, really?
Mm-hmm.
I can't wait for
Can't
tomorrow.
wait tomorrow class. Okay.
Yeah. So if you
That's
were
fine.
someone that likes to avoid trouble, what
Mm-hmm.
you would have done is to, if you want to really save yourself some stress, you would just have to
Mm-hmm.
get the input from the user first
Ah, okay.
and now start using the F, to now, say inside this, and you can now have noun here,
Mm-hmm.
see here. But some program will require that you follow the approach that we had earlier.
Okay.
Like there are
I
some
think
solutions that
the approach we had earlier is better, to be honest with you.
yeah.
Mm-hmm.
Not even better in the case, but most of the time, the way we determine what approach to, like I said, this is another approach you can follow to, arrive at the same solution. But
Mm-hmm.
sometimes when you're writing your program, that's just like programmers, you think like your user.
Mm-hmm.
You try to cover all the, any loopholes that can be in your program. Anything that can actually result in what you don't intend the program to do, you cover it before you launch it outside. That's why you're not able to do anything outside what WhatsApp allows you to do.
Mm-hmm.
Because the programmers have programmed it in the sense that they already read your minds, they know how you can you can't go I mean, above their jurisdiction. You can't go do beyond what they allowed you to do. And the reason why
Mm-hmm.
they did that was because when they wrote the logic, they've made sure that you cannot just go outside it. So when you're writing your program also, there are some to arrive at some things, there are some ways that will work best for the scenario that you want to create.
Mm-hmm.
So sometimes in your code, you may be required or it may be necessary that you have your template before you get your input. So in that case, you know that this
Mm.
approach is going to work. So that
Okay.
was why I actually had to like follow that approach. But the simpler approach in this case, because it affects nothing, it still works fine. We can get our input first and just fit it into our story templates like this. And of course, we won't have to do all this final whatever at this point. So you just have to do print story.
Mm-hmm.
You just have to say print story and voila, we have our this thing. But you also know that even if you had to create your template first, the rules still apply. The fundamental is that when you have a string, this format method works on it.
Okay.
Yeah, so those fundamentals those are what we call the fundamentals, knowing that there's a method and a method is applied to a string.
Mm-hmm.
There's a method and their method is applied to a string. So even when we had it like this, the fundamentals still hold in the sense that this format method is a string method that can be applied on a string value. Of course,
Mm-hmm.
this story is still a string, so definitely you can call the format on it anywhere.
Okay.
So any question before we
Makes
move
sense.
on to number 6? Okay,
Nah, it makes sense.
we're almost done. So this one is also very straightforward. Number 6 is very straightforward. Companies
Okay.
often try to personalize their offers to make them more attractive. One simple way is to just insert the person's name at various places in the offer. Of course, companies don't manually, just like when you sign up to a website, they
Mm-hmm.
send you like a template of a message that has already been, put in their database or whatever they are getting it from. They just insert your name there, like
Mm-hmm.
welcome, Fabrice, so something like that. They even put your
Yeah.
address, everything you've entered. You fill a form, then
Mm.
those things you've entered, they generate a message using your data, that information. And
So
when you check
this
the
they use
queries,
like Python to create those.
internally, most of most of the most of the platforms now they use Python internally because of AI. If you're doing AI, Python
Mm-hmm.
is actually like the easiest tool right now.
Mm,
Like the easiest tool right now. So like a lot, I believe if I see any platform that is using AI,
mm-hmm.
I'll be very sure that they are using Python internally.
Wow.
Almost all AI engineers uses Python. So and it's like the easiest thing to use right now. So almost everybody uses Python now. So I can tell you, even when you receive your email, like I know
Mm-hmm.
Quora, for instance, Quora, you know the Quora platform.
Which Quora?
Quora, this
No. What is this?
it's a website that you post just like your Reddit.
Oh, okay.
Yeah. So this also you people go there to post stories, you post all these things. It's very
Uh,
popular. So like
okay.
I know the guy that the guy that there's a guy that works there, a Nigerian that works there, like he's a
Mm.
friend. So they use Python.
Wow.
They use Python a lot. So like
Okay.
I mean a lot of Nigerians actually working in big tech companies. Asana, I have a friend
Mm-hmm.
also, like a very good friend of mine that works in Asana.
Wow.
That works in Asana. I have one that works with a lot of them, my classmates. Like a lot of my classmates, most of them are in the US now and Canada, London.
Wow. Nice.
So I mean, this one also just follows the same approach
We just did.
that we just did here.
Okay.
You have I mean, you should be using multi-line string here.
Mm-hmm.
So you can just attempt this. You can attempt this one. It follows.
Okay.
You just fitting in. You just putting a variable inside the template.
Okay.
So that's just what you're doing there. And for this
Mm.
last one, so this one may be a little tricky, and I would want us to. We may go above the time by 10 minutes.
Mm-hmm.
Is that, do you permit me for that?
Yeah. Yeah.
Okay. So I just want us to be done with this so that next class, we can start afresh
That's
uh,
right.
with our slide. So for this one, you know calculus, right?
Yes. So yes. Yes. Yeah. Mm-hmm.
So if you have 3s2 or 3s square,
Mm-hmm.
if you have I'm looking for the power sign. Okay. 3s2,
Yeah.
you have this 3x2. What's going to be the derivative?
It will be this one will be 9x to the power of
Ah,
2.
really? Derivative now, not
Oh, la derivé. Okay. Okay.
yeah,
Okay.
not the
Wow.
integral.
Okay. Man, I forgot that. Hold on.
That's going to be 6x.
It will be 6x.
Yeah, it will be 6x.
Mm-hmm.
You multiply the power with the
By,
coefficients,
okay.
which gives you 6, and you subtract 1 from the coefficient.
Okay. So
Sorry, from
6.
the power.
Okay.
You subtract 1 from the power.
Mm-hmm.
So
Yeah.
first you
I forgot the
multiply the
formula.
coefficient. So 2 times 3 will
Mm-hmm.
give us 6. Then you
And then
subtract 1 from the power.
it will
2
be
minus
1.
1 is 1.
Yeah.
Which is same thing as x raised
Okay.
to the power 1 is x, right?
Yeah.
Yeah, cool. So if you have similarly, if you have we're giving some examples here. If you have s raised to power 4, if you have s raised to power 4,
Mm-hmm.
it's going to be following you multiply the coefficient with the power, and the coefficient in the
Okay. So that'll be 4x3
yeah, that's going to be 4x3, exactly 4s raised to power 3.
of 3.
So this is what they want us to program. They want us to write a program that will do the calculation.
Mm,
And you can't do it in math. Where you have the math library,
mm-hmm.
you have the math library, but they want us to
Yeah.
actually implement it ourselves, implement the logic, not use a code someone has written.
Oh, they want us to do it
They
ourselves.
want us to
Okay.
do it ourselves. So that's why I say in calculus, the derivative of 4x, I mean, s raised to power 4 is 4x
Mm-hmm.
raised to power 3. The derivative of s raised to power 5 is 5s raised to power 4. The derivative of, they're giving us like, so the pattern continues like that.
Mm-hmm.
Write a program that has the user for inputs like this, like
Mm-hmm.
these
To the
powers,
power of something.
yeah, of something. It could be x raised to power 25, or even it could be, what's it called? you can have 2x raised to power 24.
Mm-hmm.
In this case, the x only has a coefficient of 1,
Mm-hmm.
has a coefficient of 1. So maybe, but then I would still like us to write a program that is robust, that can take when x has a coefficient
Mm-hmm.
other than 1. So and then I'm print the derivative. Okay, for example, if user enters x raised to power 3, the program should
Mm-hmm.
print out 3x raised to power 2.
Mm-hmm.
So
Mm.
we got that.
Wow.
Let's write our algorithm. Let's write our
Mm-hmm.
algorithm. So we know what, remember I said, when it comes to string manipulation like this, because this is an example of a string manipulation problem.
Mm-hmm.
Even like if you know it's the mathematical how it is done in mathematics, and you know the rule and everything. But at this point, we are not really all right. We are just trying. We are given a this is like the pattern. We have a pattern here
Mm-hmm.
that when you have x, I don't know what this sign is called. Is it caveat?
That one I don't know it to be honest with you.
Okay, I mean, no, it's normal. So I don't know what
Mm-hmm.
this sign is, but let's just call it a sign. Like, let's call it anything like this sign and
Mm-hmm.
a number,
Mm-hmm.
like digits. It could be any digit, anything like that. When you have them like that, then you
Yeah.
should find a way to implement the logic that would make the power to come down,
Mm-hmm.
and you
And
have the
then
x, and you have that power, and you have whatever that follows that power.
-1.
You subtract one from it.
Yeah,
That
that's
is the
one.
pattern we want to replicate. And how can we do
Mhm.
that?
Okay. So we
First,
need to, yeah,
where are we starting from?
input like X,
Thank you.
input
Inputs, let's call it
a string
not even a string, like inputs, let's call it calculus just to make it input your calculus expression.
mhm,
Let's call it input calculus expression. We have to specify what format. So C X power, this is like the format, then any digits.
mhm, yeah,
I mean MN, P, it could be any, let's just put it like that.
okay.
But that's the format standard format we're expecting. And after that, what else?
After that, once we input it, we're gonna the first
Forget.
operation,
Okay, what did you say?
the first operation, uh, it will be multiply, multiply
Okay.
the I don't know how to call that the thing
Multiply the
by
power
yeah the power by the coefficient of x.
by the coefficient. Okay. Though this is vague, but once we get down to the implementation, you see. So
Mhm.
but let's go. That's good.
And then after that, we're gonna subtract one
Okay.
from the power.
From the power. Awesome.
Mhm.
And after that,
Then print or
print
output.
out or
Mhm.
output results.
Yeah, output result.
Good. So let's calc expression. So input, right?
Mhm.
So you can say enter your calculus expression C X M N, just like the power, just to show them the pattern that we're expecting. Then after that, okay,
Mhm.
multiply the power by the coefficient, right?
Yeah.
So while we're writing our program, let's also be assuming let's like be creating like a scenario that will guide us. So let's say the user enters this. So the power is 234, right?
Mm-hmm.
and the coefficient is 3,
Mm-hmm.
or it is coming as the user enters it like that. So we say we want to multiply the power by the coefficient. How can we do that?
Multiply the power by the coefficient. Uh, hmm.
We can call
How
that
can we?
new. When we multiply the power by the coefficient, it's going to be a new coefficient, right?
Yeah.
So new coefficient.
Equal
So what's the expression?
expression here. So uh, it'll be the power multiplied by the coefficient.
How do we get the
So
power multiplied by the coefficient from what the user enters?
enter your calculus expression. So it'll be M by C.
Yeah, m by c. What is m? What is c now? M multiplied by c.
Uh-huh.
It's not m multiplied by c. Okay, let me put this. Let me just put m here. Let me not put mn. So m can be any number.
Mm-hmm.
In our case, let's say this is what the user enters. In our case, m is going to be 234. So
Yeah.
now, once we do m multiplied by c, so where is m coming from? Where is c coming from? How can we get our m and c?
Or they're coming from what the user input, right?
Yeah, of course, they are part of it. This is the
Uh-huh.
expression. The expression is coming. It contains the coefficient. It contains the calculus variable, which
The,
is our x,
the power
and
plus
the
the
power.
thing.
So
Mm-hmm.
everything there. So we now want to calculate a new coefficient. How can we calculate that?
Man, this one. So new coefficient equals to, so okay, enter the kernel. So it's gonna be this one. So we're trying to calculate, so it's gonna be this one multiplied by this. Hold on. So multiply the power by the coefficient. That's where we are, right?
That's what we have, right? Yeah.
Okay, multiply the power by the coefficient. So MC, M multiplied by C.
Yeah.
That's the new coefficient.
Yeah.
Hmm. I
Well, not
don't I don't get this one. Hold on.
okay.
Cal expression equal enter. So first is gonna enter that. And then the second one is gonna multiply the power by the coefficient.
Yeah.
So
I want you to rack your brain because the more you push is beyond limits,
hmm,
you know this rule of elasticity, right? So
mm-hmm, mm-hmm.
exactly. So I don't want to give you,
So
I don't just
I
want to
used
give
to
you
be
on a platter of
new coefficient equals, so okay, enter your calculus expression. So it's gonna first you enter that. And then are we gonna call the math thing here or not?
you're not
So-
using math or anything. Math,
Oh, they said yes, yeah.
math
They
is
say
not,
we should do it ourselves. We don't need to
math is not
call.
even going to work.
Okay.
This is not how the math module is going to work. So you
Hmm.
know the path. I mean, you already got this. You got this.
Yeah.
You want to program a pattern.
Mm-hmm.
So
So
because of our time,
yeah,
you know this is going to be a string, right?
yeah.
So even first of all, like this is going to be a string, and you cannot convert it because it actually contains a string value. This is like alphanumeric
Yes.
characteristics. Like I mean, characters that you have are alphanumeric, both
Mm-hmm.
alphabet and numbers. So you
Yeah.
cannot even convert it to float or anything. Now, but you have this coming out. The pattern is that once you have a string like this, you
Mm-hmm.
multiply this, which is everything
By
after this sign, after this, let me call it caveat, but it's not caveat. I'm not sure if it's caveat or
yeah.
anything, but let me call it
Mm-hmm.
caveat. You multiply
Everything.
everything after the caveat
Mm-hmm.
with
With the
everything
coefficient.
before the hex.
Yeah.
That is how you get the new coefficient.
That's right.
Now, after you've gotten the input, what you need to do is to get, before you multiply the power by the coefficients, once you know this is coming as a
Mm-hmm.
string, the next thing you need to do is get our extract C
Mm-hmm.
and
And then extract
extract
the coef the The exponent,
Mn, the power.
the power. Yeah. Oh, so
Extract
once you
M,
do the extra T, okay,
the power. And how can you do that? So now let's say, let's call this C. How can we get our
equals
C?
so
You already know
indexing.
we can use indexing, right? Awesome. We can
Uh-huh.
use indexing. But indexing, what if you, yeah, let's use indexing, calc expression. If we use
Mm-hmm.
0, that's actually going to work. It's going to give us 3.
Because yeah,
But what if we have our coefficient as 34 or 33?
that's the thing. Yeah.
So we
So it's
don't know
only
what
gonna
that is going to, we don't know how the pattern is, I mean, how it's going to come, except if you want them to stick to a single, uh,
mm-hmm.
what's it called? Except if you want them to,
Like single digit, yeah, then it's gonna work. But if it's double or triple, it's not gonna work.
yeah, exactly. If you want to kind of block, I mean, fix them to a certain number of
Mm-hmm.
characters. Yeah, exactly. So now our C, we can do this, but there's a method in ID. I'm not sure we did that. My
Mm-hmm.
bad. But I mean, when I asked you to research on string methods, I believe
Yes.
you would have come
The
across
very
it.
beginning.
There's a split method.
Yes, 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 yes. I remember that one. All
There's
right.
a split method. And
Mm-hmm.
once you do what split does is you specify a separator. Let me quickly, let's come here. So when you have something like this, when you have, let's create a string and say Gideon, comma, Fabrice, comma, Badly. Am I correct with the spelling? Let me check. I don't want to spoil.
Yeah.
Okay, awesome. So then dots.
So
If
you want to.
if I apply the split method and I said
Mm-hmm.
this is a single Gideon Fabrice Badly is a single string.
Mm-hmm.
I say okay now split it at I want to I need to specify a separator at comma. Anywhere there's a comma,
Mm-hmm.
split. So what is going to
Mm-hmm.
happen is it's going to result into what we call a list or an array, a collection
Mm-hmm.
of items. And what's going to be in that item is going to be uh element before each separation, but before
Mm-hmm.
the separator you specified. In this case, I said separate this particular string as every comma.
Mm-hmm.
So it creates for me a bucket. Let's call it a bucket. It creates a bucket. Once you do split, it's going to create a bucket. And inside that bucket, it will look for the first occurrence of your separator. In this case, this is where you have the first comma. Then it will
Mm-hmm.
take everything before the first comma. We make it
Mm-hmm.
an item inside your bucket.
Mm-hmm.
Then go on again, look for another comma, look for anything after the last separator till the
Mm-hmm.
next one. Anything in between, it will take it, make it another item in your bucket.
Mm-hmm.
See this, you see that the space is even included in this case. You have
Yeah.
space Fabrice and space Badly. So it basically just creates a bucket of items and include everything that was, I mean, how do I say this? It uses the separator as demarcations.
Mm-hmm.
Mind you, it is not the comma it is not the comma that we use as separator that is coming here. This is just how Python creates a bucket of items.
Mm-hmm.
It is an array, or you can, not really an array, but you can see it as an array. You know what an array is?
Yeah.
Array of items, or a bucket of collection of items.
Mm-hmm.
And you can see this particular one, it's called a list. You can see it like your uh plate rack. You can see it as a plate rack where like in your plate rack, you have plates or in order, right?
Mm-hmm.
You have your plates in order, yeah, something like that. And this one is also very ordered. This is very
Yeah.
ordered in the sense that Gideon is coming first. You can actually, it has a lot of things you can do to it. It's another data type in Python. So you can pick the first element, you can pick out all these elements. You can also do indexing. This is also a collection. And remember
Mm-hmm.
what we said about slicing and indexing. Anything in Python, you can slice or index any collection. So this indexing also works for this in the sense that
Mm-hmm.
if you say if you let's say you assign this to a variable and you try to say what do you have as your first element or as your first item, it's going to return.
Mm-hmm.
Second item is going to return Fabrice. Third item is going to return badly. Or
Okay.
something like that. So basically, what the split did is it creates an item of a collection of items. And what are the items? It is
Yeah.
part of your string values.
Mm-hmm.
Yeah, so part of your string values, uh, I mean, I don't know how to explain this pattern, but you can see here from the first one here, everything between these is made as the second element. Then
Mm-hmm.
and everything outside it is make after the. So basically, it's just create like it creates a wall or like a demarcation, a boundary at every occurrence of your separator. It creates a boundary here. Let me use this thing. So I'm coming. I want to make sure you get this right. I don't want to assume anything. So it creates a boundary at everywhere you have your demarcator, like a boundary here and a boundary here. And it will make anything to the left of the boundary and to the left and right of the boundary, it makes it as item of your collection.
Mm-hmm.
So you have Gideon here, you have Fabrice, and you have Badley with their spaces. So we have a collection of 3 items now, Gideon, Fabrice, and Badley. So same
Yeah.
approach, same thing is what we are going to use for this
Okay.
our this
For
now.
this
Let's say the user enters 34x raised to power 2 or 34x raised to power 23. The demarcate we want to split. If we're going to split, we should be using we just want to get the what's it called? We want to get the coefficient and the power. So
yeah.
what separates the coefficient and the power?
What separate is the X.
Is it just x?
X and that sign.
Exactly.
That
And now
sign, yeah.
if we do that, we have a collection of the first
34
item,
is to get,
the first
yeah.
item being the coefficient and the second item being
Second, the power.
the power.
Hmm. Senior.
So let's call it, let's say let me call this OMO so that you see what I'm 34
Mm-hmm.
x asterisk, let's call it 4 this time around. And let me say OMO dot split at every occurrence of S caveat. Let me also start that. Let me start that result in. Let me call it OMO collection, because if you don't store it, it's not changing what we have in OMO.
Mm-hmm.
So if you want to store what the output is going to be, you have to store it in a new variable. So OMO, let me print OMO. Oh, sorry. I should be printing OMO collection.
Mm-hmm.
OMO
Understood.
collection. Yeah, so you see, it gives us an
Mm-hmm.
array of
It's split.
coefficients
This is a
being the
split.
first element, yeah, and the power being the second element. And now we can say OMO collection. We can start doing indexing because this is a collection, right? So we can index or slice. But let's do
Mm-hmm.
indexing. Let's say the first element you have,
Mm-hmm.
see, it returns 34.
Yeah.
And if you do OMO collection of 1, that is the second element, is going to always give us it's going to always give us the power. So
Mm-hmm.
it is this rule that we are going to use, this understanding now that we are going to use
Yeah.
to extract
Power and the
our power.
coefficient.
Yeah. So we can say uh
Mm-hmm.
even let's know. Okay, let's say calc expression. Let me call this calc expression collection, because it's going to give this one particular one is going to give us this thing. Then after that, we can now say our C is going to be calc expression collection. What's the index of our C?
The C will be 0.
0, exactly. And for power,
The power
it's going to always
is
be in the position 1.
mm-hmm,
Yeah. So, but
because that's the end.
one thing, there's one thing we should also take note of now. I just thought about it. In a situation where there is no feasible coefficient,
Mm-hmm,
where there's no feasible coefficient, collection is going to just contain the power. That is, let me show you that. If let's say the user enters, let's say when the coefficient is 1, when the coefficient is
mm-hmm,
1, and they
mm-hmm.
say x raised to the power 24,
Yeah.
if we do the split and we say s power, you see, the first element is empty,
Mm-hmm.
and we have just the power as the only
Yeah.
value this thing there. So we should also take note. I mean, we should also. Oh, I'm coming.
Take that into consideration.
Oh yeah, it's actually not going to be a big issue like that because I actually thought nothing is going to be there.
Mm-hmm,
That was what I thought, but now it's putting an empty string there, so
mm-hmm,
it makes sense. But we should, I mean, we should have it in mind that there is something there, and in that case, when the coefficient is 1, uh,
mm-hmm,
what we are going to have in our collection as the first element is going to be an empty string.
mm-hmm,
Yeah, so we should have that in mind. So let's still continue. We have our power and we have our C. Now the new coefficient is going to be C multiplied by power.
mm-hmm,
C multiplied by power. But that's going to raise an error. I believe you also know that by now because these things are in they are in strings.
mm-hmm.
So we have to do like a typecasting, convert it to
Yes.
integers.
Yeah. Yes, that's true.
Yeah, now
Those
look,
will
now
those will be integers, yeah.
we have our new coefficients coming. And new
Mm-hmm.
power, is going to be what? What's the rule for getting new power?
It will be C minus 1. I
No,
mean, power minus 1.
power minus 1, exactly. Power
Mm-hmm.
minus 1. And now our new calc expression is going to be
Mm-hmm.
x raised to power. So now we can have, in this case, we have our new coefficient,
Mm-hmm.
and here we are going to have our new
Power.
power. Yeah, though this is still very crude in the sense that if we have, I just thought about it now, if we have let's say we only have 6x,
Mm-hmm.
to actually have a very robust solution, I think we'll have to be using some if statement or some sorts. So I think I now understand why the question only limits the express. I mean, what the user can enter to this
Mm-hmm.
with no tangible. I mean, how do I put this? Like if you check the question that is actually very specific as to what kind of input you are expecting.
Mm-hmm.
The coefficient can only be 1. So that is, yeah, the coefficient that the user is going to enter can only be 1. It says when you enter stuff like this, s raised to power 3 or s raised to power 25.
Mm-hmm.
So that's what the question says. But let's just assume this is what we want to work with. The trick is going to be different. Let's say this is what we want to work with. If we print this now and or let's follow what the question says so we don't, oh, we've gone beyond. Okay. So let's make the assumption that the coefficient will always be 1.
Mm-hmm.
The coefficient will always be 1. And we are not getting any holds distance C because we already know that the C will always be 1. So, but the power is always going to be at position 1. You all know that also, right?
Yeah.
Yeah, good. Then we can say to get the new coefficient is going to be power. Let's say, since that we know our C will always be 1, so C equals to 1 is always 1. So new coefficient is going to be power multiplied by C. And of course, our C is 1. And after that, new power is power minus 1. And new, what's it called? The new calculus expression is going to be new coefficient X power, then the new power, and we are good to go. So
And
one
then
other
print this.
thing is, one other caveat is that your power must not be 1. Your power must be greater than 1. That is when this
That's
code
right.
perfectly without an issue. So if you run this now, I will say x raised to power, sorry. Power minus 1. Okay. So if I say x raised to power, so let's take from the example they gave here, x raised to power 4. We should have 4x raised to power 3.
Yep.
Which works fine. So if we run it again,
Program works great.
we have x raised to power 5. If we have x raised to power 5, then we should have 5x raised to power 4.
Yeah.
And good. So
Nice.
that's that about the solution. I think that is all. Yeah, awesome. So let me know, waste our time. Take our time
Yeah.
for.
I'm gonna go through the video again, then do these things step by step again to understand more. But it
All right.
was clear everything that we did today.
Okay, awesome. Awesome. So thank you so much. We'll call it a
Thank
day
you.
by next
Yes.
week.
Thank you so much.